Hai, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad HAMIDI, and today I'm going to tell you about the introduction of the compressor. Do you know what is compressor? Compressor is a user's mechanical work to take an amount of fluid and deliver it to required pressure. And next, an efficient compressor increases pressure with minimum work. And next, the amount of fluid is limited by the volume of the compressor cylinder, which is fixed. And next, the reciprocating compressor operates in a cyclic manner. Okay, and the last one is the properties of the working fluid at the inlet and the outlet are the average values. And next, we go through to the basic component of a reciprocating compressor. Alright, okay everyone, now we go through to the basic component reciprocating compressor. Okay, as we know that a compressor have the connecting rod and the crankcase and the crank, piston, delivery valve, outlet and an inlet. Okay, for the first one, I want to explain to you all about the crankcase. Crankcase can enclose the compression volume. And next, we can move to the crank. The function of crankshaft rotates. It rotates this one. The crank it rotates this crank. Okay, for the connecting rod, crank and the connecting rod is connecting. Both is connecting the crank with the piston. So here is the piston, and the function of piston, it moves through the cylinder during each cycle. So it moves through the cylinder during each cycle. For the crankshaft, the function for the crankshaft is rotates the crank. So here is the crankshaft takeover. The crankshaft is usually driven by an electric motor. This is a schematic layout lah. Okay, here is a drawing for the compressor that we use in our daily life. Okay, the first one is a air intake. So at here, the air take over this. For the second one is the compressor pump. Here is the compressor pump. And the third one is the outlet. The outlet is connecting from the compressor pump, and the flow is through by the drive. Okay, for this one, this is a drive belt. So it's rotating motor here, and here it is control switch. We can control the compressor. Okay, for this one is a relief valve here, and next is the pressure gauge that we can take a value from this one. We can take the value of the pressure that we can take from the pressure gauge. And here is the manifold. For the here is the regulator, and this one is a supply line. Supply line is connecting by this one. And for this one, we also know this one here is the tank lah. Is the air tank. And for the next, water drain. Here is a water drain. Okay, that's all from me.
Assalamualaikum and hi, my name is Muhammad ALIF bin AHMAD TARMIZI, and I will be explaining about the working cycle and the PV diagram for the reciprocating compressor. Okay, this is the slide for my working cycle and the PV diagram for the reciprocating compressor. As you can see in the slide, there is 3 parts, which is the explanation on the points of the cycle. On the right below, there is the PV diagram, and right at the top is the diagram for the reciprocating compressor. In this reciprocating compressor, there's a pistons, the delivery valve, and the induction valve. Okay, as you can see here, there's is marked V1 and V2, which represent the motion or the top dead center and the bottom dead center, which in this diagram, the top dead center is at point V2 and the bottom dead center at V1. Okay, this diagram is synchronized with the PV diagram, which at V1 is same at PV diagram. V1 at F, V2 at point E. Okay, now I will explain about the strokes involved in reciprocating compressor. For induction stroke or the intake stroke, the induction valve will open as the piston move from point V2 to V1. This motion will allow the air to induce into the cylinder, which causing the volume and mass increases in this cylinder. The pressure and temperature is remain constant during this process because the induction valve was open. The next strokes is the compression strokes, which the inlet valve will closes. The inlet valve closes and the piston move from point V1 to V2. These pistons will compress the air, causing the pressure to rise until P2. Here, the P2, the maximum pressure as the piston goes to point V2. As the pressure increases, the temperature will also increases. The next strokes is the delivery strokes, which the delivery valve opens. Delivery valve opens. The high pressure air from the compression strokes will be delivered through the delivery valve to the desired tank or other applications. The pressure and temperature is remain constant because the valve was open, so there will be no difference on pressure and temperature during this process. As you can see here, at the curved line can be represented with the polytropic process, or for the compressor we use the reversible polytropic. That is all for the working cycle and the PV diagram.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AIDIL bin AZALI, and I will be explaining example question of single stage compressor. So the question is, a single stage, single acting air compressor running at 1000 per minute delivers air at 25 bar. For this purpose, the induction and free air condition can be taken as 1.10 bar and 15 degrees Celsius, and the free air delivery as 0.25 meter cube per minute. The clearance volume is 3% of the swept volume. Calculate the volumetric efficiency of the machine. Take the index of compression and expansion as 1.3. Calculate also the indicated power and the isothermal efficiency. So I will be show the calculation of this question.
Before we go through the calculation part, we have to jot down all the information that we can get from the question. So this is all the important information that I can get from the equation, and we have to draw the graph for single stage compressor. Now let's move on to the first question. So the question asks us to find the volumetric efficiency. So the first step is to find the V actual first. So the formula for V actual is m dot time R times T per P. You can get the value is 0.25, and then the step 2 we have to find a cycle for that can be induced. 0.25 times 1 over RPM, which is 1000 per minute. So this value we categorize it as equation 1. So the third step is we have to find the value of VA in the term of VS. The equation in VS is equal to VA minus VC. So as we know that VC, the value VC is 3% from the VS. So it becomes VS is equal to VA minus 0.03 VS. So from there we can get the value of VA, and we categorize this as equation 2. Then for the first step we have to find VD. For VD, the formula is VC times P2 over P1 in the power of 1 over N. So as we know, as I said just now, the value of VC is 0.03 VS. The value of P2, which is 2500 over 101.3 in the power of 1 over N, and we know that the index is 1.3. So we calculate this value and we can get the value for VD in the term of VS. This will be categorized as equation 3. So enter equation 2 and 3 into the equation 1. So we can get this type of equation. From this equation we can get the real value of VS, which is 3.69 times 10 in the power of negative 4. So this value of VS need to time with 1000, which RPM. We can get from there we can get 0.369. So the last step to find the volumetric efficiency is we apply V actual times VS value. So we can get the value, the volumetric efficiency is 67.8%. Second, the question asks us to find the indicate power. So as we know, before we continue with finding the value for indicate power, first we have to find the value for temperature 2. So for the formula for the temperature 2 is T2 is equal to T1 P2 over P1 in the power of 1 n minus 1 over n. So we substitute all the value into the formula. We can get T1 is 288 Kelvin, P2 is 2500, P1 is 101.3, and the index value is 1.3. So using the formula, we can get the T2 temperature to value, which is 603.5 Kelvin. So from there, we can calculate the indicated power. So this is the formula for indicated power: N over N minus 1 time M dot time R time temperature 2 minus temperature 1. So we substitute all the value into the formula, and we can get the indicated power value is 2 kilowatts. Okay, moving on to the last question. The question asks us to find the isothermal efficiency. So before we find the isothermal efficiency, we have to find the isothermal power. The formula for isothermal power is M dot time R time T1 ln in the bracket P2 over P1. So we all know from this formula, we all know the value. So we just have to substitute the value into this formula. So from the formula, we can calculate the isothermal power, which is 1.35 kilowatts. Then we can find the isothermal efficiency. The formula for isothermal efficiency is isothermal power over indicate power. So we have the value for isothermal power, which is 1.35 kilowatt, and the indicated power, which is 2 kilowatt. So we use the formula, we can get that the isothermal efficiency is 67.5%. So that's all from me for the example question for single stage compressor. Assalamualaikum and thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is HANIF bin MOKHTAR. Today I want to share the example question for multi-staging of a compressor. The question is a two-stage single-acting air compressor compress air to 20 bar. The air enter the LP cylinder at 1 bar and 27 degrees Celsius and leave it at 4.7 bar. The air enter the HP cylinder at 4.5 bar and 27 degrees Celsius. The size of the LP cylinder is 400 mm diameter and 500 mm stroke. The clearance volume in both cylinders is 4% of the respective stroke volume. The compressor runs at 200 rpm. Taking index of compression and expansion in the two cylinders has 1.3. So the question is estimate the indicate power required to run the compressor. So from the question, we need to list all the important points in the question before we start to answer the question. And after list all the important points, and we sketch the PV diagram to make us understand the flow of the compressor. After that, we start to answer. And okay, first, to find the indicate power required to run compressor, we should know the sweat volume of LP cylinder first. So the sweat volume 1 equal to 5/4 times D1 D1 square times L1. So apply this formula and we can get the answer 0.06283 meter cube. After that, we should find the volumetric efficiency, and the formula of volumetric efficiency is 1 plus K minus K times P2 over P1 power of 1 over N. and we use this formula, and we can get the answer of the volumetric efficiency is 0.9085. So from the sweat volume and volumetric efficiency, we can get the volume 1. So the formula is to find the volume of S sucked by air pressure compressor. The formula is volume sweat time volumetric efficiency. So use this formula and we can get the answer of the volume 1 equal to 0.0571 meter cube. After that, to find the volume flow rate, we must multiply the volume with n, and we can get the volume flow rate 11.42 meter cube per minute. And from the volume flow rate 1, we can get the volume flow rate 3. So to find the volume flow rate 3, we must use this formula. P pressure 3 times volume flow rate 3 equal to pressure 1 times volume flow rate 1. So use this formula and we can get the volume flow rate 3. The volume is 2.54 meter cube per minute. Okay, after that, to find the indicate power by LP compressor, the formula is N over N minus 1 times pressure 1 times volume flow rate 1 times P over P2 or pressure 2 per pressure 1 power of N minus 1 per over N minus 1. So from this formula, you can get the answer of the indicate power for LP cylinder. So the indicate power for LP cylinder is 2124.07 kilojoule per minute. After that, to find the indicate power by HP compressor, we just use the same formula, just change the pressure and volume, and use this formula, and we can get the indicate power of HP cylinder, HP compressor. So the answer of indicate power of HP compressor is 2035.19 kilojoule per minute. So to get the indicate power for all, we should plus all the indicate power HP and LP. So from that we can get the answer, the indicate power for overall the cylinder. So the answer is 4159.26 kilojoule per minute. So we must divide 60 seconds to get the answer in kilowatt. So the answer in unit kilowatt is 69.3 kilowatt. Therefore the indicate power compressor is 99.3 kilowatt. That's all from me. Thank you.